Hare Krishna to all the viewers and welcome in this video where today we are going to discuss about ICSE Class 10 Physics Chapter 1 Force. Now before moving forward I want to clarify a few things. First, the language of this content. So the language of this content will be mostly in English, but कुछ ऐसे जगहें होंगे जहाँ पे कुछ examples को explain करना होगा तो वहाँ पे मैं हिंदी का use करूँगा. But this content is mainly for English medium students, so most of the content will be in English. Okay. Next thing is visualization. So whenever we try to understand any concept, it is very important to visualize it. It is very important to use examples to understand the concept. So we'll try to use as much examples as possible in our videos so that we can easily understand the concepts. Okay, so now this video chapter 1 is about force. Let's first revise about force. Okay, what force is all about. Now whatever we have studied before about force, right? So force is from Newton's second law. We know that force is the rate of change of moment. Force, so the SI unit of force is Newton, and what is the CGS unit of force? So the CGS unit of force is dyne. So these are the few things which we have already studied before. So this is just a revision. Now moving forward, when we apply a force on a body, there are two types of motions which are produced. One is linear or translational motion. The other one is rotational motion, right? For example, let us imagine that we have any table in front of us, right? When we are applying a force on the table will move, right? In a linear way, in the forward direction. So that force is your linear or translational motion. But that force produces linear or translational motion. But we have this pen, right? Now let us consider it is fixed at a certain point, but it is pivoted, okay? You may have seen the word pivot in your book also. So what is pivot? Pivot means it is fixed at a certain end. So this pen, suppose we have it fixed at a certain end. Now when we apply the force at the other end, a rotational motion is produced, right? So this other type of motion is known as rotational motion. This motion is also seen in door. That suppose we consider a door. The door is fixed to the hinge, right? And when we apply force at the handle of the door, it will rotate about the axis of the hinge. So rotational motion and we have linear motion. These are the two main types of motion. There is also uniform circular motion, about which we will study later in the chapter. Now the important thing here is your rotational motion. Now rotational motion is produced due to the turning effect of the force, right? This turning effect of the force is known as your moment of force or torque, right? So what is this torque? What is this moment of force? Now let us consider any body, any object. Like suppose this is the wheel. This is the wheel, right? You can see this is the wheel. Now this wheel is suppose fixed at this point. This is the point of pivot for the wheel, this center point. So this wheel is fixed at the center, and when we apply a force tangentially at the rim of the wheel, मतलब जो हम लोग ये wheel का edge है, यहाँ पे जब हम लोग एक force apply कर रहे हैं, when we are applying force tangentially on this wheel, the wheel is rotating, right? So a turning effect of force is being produced when we are applying force here. So this wheel is fixed at a certain point, and when we are applying a force, a turning effect is produced. Now what is happening? This turning effect or moment of force depends on two factors. First is your magnitude of force, means the more force you will apply, the more will be your moment of force. Second is your distance of the application of force from the axis of pivot. Okay, so suppose this is the axis of pivot, this is the axis of pivot, right? And here we are applying the force, right? So the more the distance, the greater will be the force applied. Now once again, if you want to understand this concept with the help of the example of a door, so you have seen the handle of a door is always at a greater distance from the hinge. It is not located closer to the hinge. It is at a distance greater from the hinge. Why? Because we can apply a very small force at the handle to open the door. If the handle is at a closer distance to the hinge, then we need to apply a greater force to produce the same amount of moment, right? So this is the concept. Moment of force is equals to force into distance. Magnitude of force into your perpendicular distance with the axis of pivot. Okay, so this is a very important point to note. Now we know the formula of moment of force, which is force into distance. So from here we can derive the SI unit for moment of force. So the SI unit will be Newton meter, because Newton is the SI unit of force, right? And meter is the SI unit of distance. So your SI unit of moment of force will be Newton meter. Very easy, right? Now moving forward, there are two types of moment of force, right? One is your clockwise moment, another one is anti-clockwise moment. Now clockwise moment is, suppose we have this pen. Okay, this is this pen, or consider this as any body which is fixed at a certain point, right? So when we are applying a force here, it is rotating in the clockwise direction, right? So this is producing a clockwise moment, and when we are applying a force here, it is rotating in the anti-clockwise direction, right? When we are applying here, it is rotating in clockwise direction. When we are applying it here, it is rotating in anti-clockwise direction. So when we are applying the force in clockwise direction, it is producing a clockwise moment. When we are applying the force in the anti-clockwise direction, it is producing an anti-clockwise moment. Okay, it is as simple as that. Now when we will do the calculation, when we will do the numericals, for the ease of numerical, we always consider the anti-clockwise moment to be positive and the clockwise moment to be negative, right? So this was all about your moment of force. Moving forward, there is another concept which is known as couple. Okay, so couple is what? That for any body to rotate, if you want to make any body rotate, there cannot be only a single force which can rotate the body. There must be two forces acting together, right? These two forces together are known as couple. So basically couple are two equal and opposite forces, right, which act together to rotate a body. For example, when we are, again, if you take the example of a door, so when we are applying force on a door, then what is happening, that your force is acting on the handle, right? When you are applying a force at the handle, and another force is acting at the hinge, and equal and opposite forces acting on the hinge. But the force which is acting at the hinge is producing zero moment, because the distance from the point of pivot is zero. Okay, so this is your couple. Now you must be thinking, why am I again and again using the example of door? There must be some other examples as well, right? Obviously there are other examples. For example, this spanner. Okay, this is a wrench or spanner, which we know. So if we consider this as an example, now if we want to open a screw from this, right, if at this end, right, and then we will apply a force like this, right? So when we are applying a force at the end of the handle, then we can produce a large amount of moment by applying a small amount of force. But if we apply the force at a closer distance, at this point of the handle, then we need to apply a large amount of force to produce a large amount of moment, right? So the greater the distance, the greater will be the moment. From this example, we can clarify this, or we can see this. Another example is your hand flour grinder, मतलब जिसको बोलते हैं ना चक्की पीसना. You have seen in many movies as well कि चक्की पीसना होता है. So there also there is the grinder, मतलब the handle of the grinder is मतलब it is suppose something like this. So it moves like this, right? So the grinder is at a greater distance from the point of pivot. Okay, so that a large amount of force can be produced easily. Okay, by large amount of moment can be produced by applying a small amount of force, right? Moment and force both are different things, right? Important to know, because when I am giving the examples, it may sound a bit confusing that moment and force are similar or what, but moment and force are different. Moment is for your rotational motion, right? And force is for translational motion. So these are the few things which we need to remember. Okay. Now moving forward, there is another concept which is known as moment of couple. Now here I have drawn something. I don't know if it is properly visible or not, but basically there are two ends, right? Let's consider here that there are two ends. Suppose this is end A, this is end B. Now the pivot point is at the center, okay, which is O. Now two forces are applied. One force is applied at end A and the force is applied at end B. Both the forces are opposite in direction, but both the forces are opposite in direction in such a way that they are producing anti-clockwise moment. Okay, matlab if I am applying a force here, okay, so ये तो clockwise हो गया. If I am applying a force here, मतलब ऐसे करके मैं apply कर रहा हूँ, okay, if I am applying a force here, it is producing anti-clockwise, right? It is producing anti-clockwise moment. And similarly, if I am applying a force here, ऐसे करके जो मैं इधर apply कर रहा हूँ, so it is also producing an anti-clockwise moment. Clockwise is like this, anti-clockwise is like this. So when I am applying a force here, it is anti-clockwise. When I am applying a force here, it is also anti-clockwise, right? So if both the moments produced are anti-clockwise and both the forces are same, both the forces are F. Okay, if you can see the diagram here as well, I don't know if it is properly visible or not, but if you can see the diagram, there are two forces F which are in opposite direction, but both are producing a similar moment, which is anti-clockwise moment, right? And the distance between the two forces is d. So suppose this distance is d. So the moment of couple will be F into d. Okay, you can see the derivation in your book as well. It is very simple to understand, but still if you have any doubt, you can ask me in the comment section as well. Okay, so this is all about your moment of couple. Now moving forward to the last topic for our today's video, which is equilibrium of bodies, right? Equilibrium of bodies means so far we have considered that only one force is being applied on the body, but it is possible that more than one forces are applied. Okay, so if more than one forces are applied, and if the forces are applied in such a way that your body remains in the state of rest or in state of motion, then it is said to be in equilibrium. Okay, so there are two types of equilibrium. One is static, another one is dynamic. Static means what? Ki suppose a box, okay, a box is lying on the floor, okay, and you are trying to push the box in the forward direction, and somebody from the opposite direction also trying to push it. Okay, जब दोनों opposite forces apply कर रहे हैं on the box, तो क्या हो रहा है? Box will not move. Okay, the two forces will cancel out each other if they are equal in magnitude. So the box will remain in the same position, in the state of rest. Okay, so this is known as your static equilibrium. Okay, next there can be another example like a beam balance. Okay, you have seen a beam balance where there are two parts, एक part पे कोई एक जन बैठा and another part पे एक और जन. Now if both the person दोनों जो है वहां पे if they have same weight, then what will happen? The beam balance will be in the same state, in the state of rest, right? It will not rotate up or down. It will be in the same state. So that is also a condition of static equilibrium, right? Next we have a state of dynamic equilibrium. So dynamic equilibrium is something which we will be able to understand more clearly when we will study your uniform circular motion or when we will study centripetal and centrifugal force. But dynamic equilibrium is something which can be seen in the planetary motion. So that is because of the centripetal and centrifugal force. When we will study that in the upcoming videos, we will be able to understand it more clearly. Another example is raindrop falling from the sky. So when the raindrop is falling from the sky, there is a force of gravity which is acting on the drop, right? And then there is a force of buoyant force. There is a air friction in the air also. So there are multiple forces which are acting on the raindrop, which is keeping the raindrop in the state of motion, right? So this is also an example of dynamic equilibrium. So equilibrium, basically there are two types, static and dynamic, and a body is said to be in equilibrium if the moment of forces are equal and opposite, and if the forces are equal and opposite. Okay, for linear motion, if the forces are equal and opposite, then the body can be in equilibrium, And for rotational motion, if the moment of forces are equal and opposite, then the body can be said to be in equilibrium. Okay, so this is the concept, basically whatever we have studied so far. I hope you understand it. I know, I mean, it can be a little bit difficult to understand in the first go, but you can watch this video multiple times. You can read the books as well. Reading book is very important. Okay, read your physics book properly. There are many more examples in your physics book, so try to read it properly. If you have any doubt, if you want any clarification, you can ask me in the comment section, and I will be very happy to help you. Thank you for watching this video till the end. Stay safe and be happy. Hare Krishna.